Professor. Hello, I'm Professor Kyle Shen, teaching physics 1116 for fall of 2010. Yeah. Today we're going to learn about energy because you're not Richard Feynman. Yes, you should always panic. So it comes crashing down like the North Korean space program. I assume none of you are from North Korea. I don't know what they did in the 50s. Probably just held their head in their hands and cried. I'm sure you'll be hit by a proton, but you'll be okay. Problem set 8 is here. Otherwise, have a good weekend.
Professor, can I get an extension?
I don't negotiate with terrorists. Thank you.
Hi, I'm Greg Feeney, and I'll be teaching spring 2011 physics 2217. And I'm bothered by something, but I don't know what. After all, it's inherently a quantum problem, but so what? I most likely won't be your first quantum mechanics teacher, so this is good for me. So let's analyze a spherical system. So this is one of the most conceptual concepts in the course. We have this spherical shell. Now we gotta make sure we integrate it, because that's ENF, we do that. So anyway, I take this spherical shell, and after I integrate it, I'm done. But whatever, I'm from Philly, leave me alone. Oh, and if you have any questions, just send me an email. Or I'll send something through blackmail.
Hi everyone, I'm Professor Kim, and I'll be teaching 2218 for the fall 2011 semester. Now, wake up everybody, in the case you get sleepy at the sight of my face. If you don't understand the lecture today, there's a good chance you'll hate me. The key point, it will be very important to remember that 1 + 1 = 2. And now, for this problem, with dollar being so weak, let's say we have a slab of gold. If you think about people living in the 18th century, they didn't have iPads. They were basically Neanderthals. And finally, as an example of the transitive property, I love my husband, and my husband loved his mother. Does that mean I love my husband's mother? Well, I do love her, but you could imagine a different situation. This class is like blah, but I like you guys.
Good morning. Welcome to Applications of Quantum Mechanics. Today we will talk about the lamb shift. Lamb, not like animal. We will also talk about quantum field theory. In quantum field theory, everything around you is quantum harmonic oscillator. Tickling everywhere. Tomorrow your friends will be presenting the seminars. If you are late, there will be punishment.
I told them about the lamb.
That was our prelude. So now, as our official skit, the physics department was in dire need of introducing a new course into our roster, Physics 8000, cross-listed Hotel 101, how to get dressed in the morning. And the first professor that decided to try to teach this course was Professor Maxine Karlstein. And my friends and I had the pleasure of having him this semester. It's just a kind of forward to the situation. He teaches other class in the hall from Professor Kim's class, who has some very interesting demos, including some musical instrument demos. Zach, enjoy the skit.
So when you get dressed in the morning, the most important thing to start with is the socks. Okay? So intuitively, you can see from your intuition that this is supposed to go on your foot. Alright, now, the derivation is a little involved, so I'm going to put on the problem set, but basically the goal, and we're done, we put it on the foot. Okay? So I kind of want you guys to go through the derivation. It's really important work. Anyway, so the next thing we have is so when we have the pants, we've got to make sure to fuck them on the legs. And you can tell this because they have 2 holes right where your legs are supposed to be. So you put your legs through the shorts, and that's how you make sure you got them on correctly. And when you put this on yourself, you can make sure you're almost halfway done. Okay, I can't do this anymore. Anyway, I'll just finish this next lecture.
Okay, so today we're going to be discussing the canonical dressing function. So we know that in the canonical function, you getting dressed in the morning is an isolated system attached to a reservoir that can exchange clothing. So we know that getting dressed in the morning is related to putting on your shirt plus your pants plus your socks. Now, we're just going to put partials in front of all the turn on a little bit, and move them all over the place. Eventually you get the relationship. Now, we know that the probability of getting dressed in the morning is a function of your socks. So, what we're going to do is we're going to tailor expand around the natural log of your socks. And if the end socks is large, we can approximate it. And when you do this, you can find the probability of getting dressed in the morning. Thank you.
This is gonna be so jittery.
Sorry. Okay. Unfortunately, the next day, everybody showed up in only their socks. We had to let Professor Thorne go. So his replacement then was Professor Ivan Bazarov.
Good morning. Welcome to applications of textile fabric. Okay, so we know we start in the morning in an undress state. We'll use familiar notation, the rock notation, yes? Okay, so undress state, go to dress state. Now, so we need to find operator that take dress state to undress state. So we will start with sock operator, followed by shoe operator. Now, very important to note, you see sock operator do not communicate. Now, back in Russia, my professor said if someone can decide and figure out how to put shoe on before sock, you do not have to come to class anymore. So I studied very hard for 2 weeks, and I figured it out. I tunneled socks through the shoe. So I don't go to class anymore. Wonderful. Okay, so you are very smart. You should know the rest of the material. I put lecture notes online. Quiz tomorrow morning.
2 days later, the results of the quiz came in, and everybody proceeded to drop the course because the mean was a -1. So we filled the class with unsuspecting new freshmen and got Professor Grossman to teach them.
Good morning. So today I'm going to teach you all how to get dressed in the morning. Now, a good place to start would be your socks and your shoes. And you can see by the shape of the socks and the shoes in this picture that the shoe is basically small perturbations about the sock. So you can tailor expand about the minimum of the sock, and it's rather trivial to show that trivially you put on your shoes after you put on your socks. Now, following the shoes and the socks, we have shirts and pants. Now, for this part, we can approximate the human body as linear arms and legs and a spherical head. And it's trivially trivial to show that the shirt trivially goes over the arms, and the pants go over the legs trivially. So this is pretty trivial. You know, physics is easy. It's like riding a unicycle. So, do any of you by any chance play water polo? I mean, anyone? Show of hands? No, nobody? Well, that's unfortunate. Water polo is a really great sport. It's one I think you all should try sometime. I don't know if any of you saw the game yesterday, but it was really amazing, I thought, how the team in behind came back at the very end. None of you saw? That's a shame. Good lecture. See you all.
Everybody was actually recruited to Professor Grossman's water polo team, so there was nobody left in class. The next semester, actually, we got a whole new class of people, and we got Professor Sethna to instruct.
Hey, good morning. So, today we're going to begin talking about how to model putting your clothes on in the morning. Now, different people have different approaches. I like to do the bottom-up approach. And the reason for that is because you get to put your sandals on first. But, you know, most people like to put their socks on first, so I think we should probably start with the socks. Now, when you take the socks out of your drawer in the morning, they're going to be flat. But then once you put your foot in them, they're going to deform. We have to make sure that they don't deform into a shape that won't fit in our sandal. So, let's begin. So, we have our sock. And we know that the sock's made up of very, very tiny threads. So maybe we have something that's like ordered 10 to the third threads or something. And what we should do is we should start with each thread and split it up into index points along the thread from 1 to n. And let's say we have 10 squared points. Now we want to be able to measure and balance the forces and the interactions between all of these. But that means we have to sum the forces over a very large set of data. Now, this is very difficult to do, but it's good to show. If we have a very poorly made sock, it's okay. But if we have a silk sock, it's not. So if you go actually and turn to page 10,052 in numerical recipes, there's a very detailed explanation of all this. And you know, it's very interesting. One of my grad students once, he did a project. He applied some of this stuff to magnetic systems, and I think I have some transparency somewhere. I've seen they've left them at home, but it looks like we've run out of time. So tomorrow we'll cover at least 5 more different methods for modeling textiles, and from there we can move on to the samples. Thank you.
Dropped from the roster, unfortunately, for the physics majors. And that's our skit for this evening, so thank you so much.